Okay, we come now to the final question on paper 1 anyway, exercise 7 for paper 1. Now this is one of the more tricky questions, but we can do it. So, Misha and Tigran want to improve their chess playing skills. They decide to play mini games to train. Tigran starts by playing 6 games a day, 8 games the next day, 10 games the next day, and so on. So first off, we immediately should be able to see, okay, we've got here an arithmetic sequence. So I'm just going to write arith. So that's obvious. That this is very clearly some kind of an arithmetic sequence. Misha starts by playing 1 game, and then 2 games, and then 4 games. And I hope then that it must be clear that this is probably a geometric one then. This is probably a geometric series. So, okay. Now that that's out of the way, that kind of gives us a starting point for the other questions that we're going to get. So the first one is, determine how many days must pass until Misha plays more games in a day than Tigran. So the best solution here is honestly to just experiment and see what happens. So if we follow this pattern along, 6 games, 8 games, 10 games, then you have 12 games, then you have 14 games, and then 16 games. You would simply continue the pattern, right? For Misha, it's 4, and then it's 8, and then it's 16. Whoa, hold on a moment. So here, this is when Misha overtakes Tigran. So day 1, day 2, day 3, day 4, day 5. So the 5th day, that's when he overtakes. So if you say 5 days, I'm happy to accept that answer. There is a, well, yeah, okay, yeah, I'm gonna say 5 days. So let's make some room. That was the first question, though. The next question is, determine how many games Tigran will have played in total on the 20th day. How would you do this? What I want to point out here is this in total, because a lot of people, it seems like, miss this entirely. But the idea is in total. You want to add up every single game he's played on the 20th day. You don't want to simply find how many games he plays on the 20th day. You want to find how many he will have played in total on the 20th day. All of the games before that added up. That sounds an awful lot like a series kind of question. And you would be right to think so. So there, you would simply look in your formula book and you would find the formula for an arithmetic series. And I think that it goes something like this, although you must bear in mind that I'm doing this by memory, so I might be wrong. But here, you can simply do U1 plus U1 plus the common difference, I think, times n. Could that be right? I think it actually is, if I'm not mistaken. Because the idea is, oh, except it's n minus 1. Yes, I think this actually works. And we'll find out. And if not, then I'll re-record this part. So here's what we do. Sn equals 2. And then you simply say, well, how many days we have? Well, we have 20 days. So we're going to do 20 divided by 2. And then our U1, what is our U1? Well, he starts with 6 games, so I'm going to put 6 in. Then after that, then I'm going to put in 6. Then I'm going to put in the common difference. The common difference is 2, because he plays 2 more games every day. Then I'm going to put in 20 minus 1. Okay, let's see what this gives us, and see if we get a nice result. Hopefully we do. So the first thing that we do is we say, well, let's simplify a little bit. That can be equal to 10, and then in here we can have 12, and then over here we can have 2 times 19, which is then all equal to 10 times 12 plus and then 19 times 2. Well, that's 38. And this is then just 10 times 50 if you do the math, if you do the legwork, and you get 500 games. And if I remember right, that's also the correct answer. So I think I got it right. Okay, so 500 games. So that is now A and also B out of the way. Let's move on to C. Determine how many games Misha will have played in total on the 7th day. So this is a slightly different question because now we're dealing with Misha. Now, this one, you would have to find your series formula for your geometric series. Now, I'm going to just quickly make sure that I have the right formula for it, but I think that I do. So, here's what we're going to do. We're going to write it down. We're going to say, okay, well, Sn should be equal to it should be equal to U1 multiplied by, and then in a bracket, it should be the 1 minus R to the N, then divided by 1 minus R. Okay, let's try and do this. Misha starts by playing 1 game. So that's our U1. Then in here we need to have 1 minus 2 to the 7 divided by 1 minus 2. Okay, let's try our best. So first off, what is 2 to the 7th? Well, we're just going to have to find out, aren't we? 2, that would be for 2 to the 1. Then you would have 4, and then you would have 8, you'd have 16, you'd have 32, you'd have 64. So that's, let's see here, this is 1, 2, 3, 4, 5, 6, and then finally 128. So what we have here is 1 times 1 minus 128 in a bracket divided by 1 minus 2. This is then 1 times 127, but with a minus because we have that. But the thing is, it's going to disappear because at the bottom we would get minus 1. And that would make it minus divided by minus, and the minus would disappear. So the answer is pure. It's simply 127 games. So now we come to the last question. And I'm going to give myself some horizontal space to work with it. So this one. Chess often uses an ELO rating system to estimate players' skill. Misha's ELO rating as a function of time can be described by the function f of t equals to 200 times log base 7 of 3t plus 6 plus 300, where t is the time Misha has been playing in days, and f is Misha's ELO rating. Calculate how many days Misha must play to reach an ELO of 700. So our first step should always be to write down the condition here. We're interested in when does his ELO become 700? If it's 200, if we know that you can get his ELO as a function of time like this, 3t plus 6, and then plus 300 at the end, we know that we can set that equal to 700 and then basically just try and solve for t. This little variable hidden in here, which is looking more and more ugly by the second, but that's life. Okay, we have all of that ready. Now, let's try and actually solve this bad boy. We have to remember our order of operations here. We have to remember that there's this plus 300 out here, but we have to take that first because we cannot undo logs, we can't do multiplication until we get rid of all of the plus and the minuses. So we're going to subtract 300 on both sides and get 400. And 200. And then in here, we still have our log in base 7 of 3t, then plus 6. Okay. Now, the next thing is then we go, well, I still want to get rid of this log somehow, but I can't get rid of the log yet. I have to do this 200 first. That means 400 divided by 200. Well, that's just 2, right? Because 2 times 200 would give you 400. So if I divided them both by 200, it would be 2 on this side. And then I still have log 7 of 3t, and then plus 6. Okay. We're almost there now. Because now, the final step is to get rid of this log. You may not remember it, but the way to do it is to look at what it has for the base down here. Then you simply set that as the base for an exponent. So this 2 gets to sit up here. And then on the other side, we get 7, and then with log 7, 3t plus 6. What's interesting about that is that while over here we know that this is going to equal to 49 very quickly, we can do that in our head. We can do that with the times table. Over here, we can very quickly find out that this and this, by some logarithm rules, will cancel, and we'll just have 3t plus 6. And now, well, look at that. We can actually isolate for t. By subtracting 6, that gives us then 43 equals to 3t. And then we can simply divide everything with 3. So that we get 43 divided with 3 equals to t. And that would actually be enough for me to say that that's fine. Like you could manage with this. However, if you want to do a little bit more, you can actually find out by hand that this is going to be equal to, one moment please, 42, yes, 42, so that should be then 14.3 days. And I'm happy to accept either answer, but that is the procedure, is to remember your logarithm rule. Remember that you can just take this base, take everything on both sides to that power if log is the only thing left. Only if log is the only thing left. So you have to be in this kind of form. Then you can take this and put that as the base for both sides. Put everything in an exponent. The log will cancel with the base on the side where the log is. Everything will stay the same on the rest of it, but you can do those calculations. Like you can do 7 to the 2, and you can get all of this stuff.